So we'll open it up for discussion. I think Mario's last question is the question that we'd like to sort of get a glimpse in what other people are thinking. There's been a lot of discussions that have happened. There may be some questions that based on things that were said here. You're welcome to do that, but let's open it up now. So who'd like to start? Danny?
We have to avoid the pitfall of trying to artificially reduce the uncertainty because now we are still at the stage, as I showed in my presentation, when we know more how much we don't know, and when we add these processes to the models, then we expand the room of possibilities, and the uncertainty increases. And we have to explain to society and policymakers that if we are actually not increasing uncertainty, but increasing uncertainty, it's not that we are not doing our job right.
Yeah, that's right. Let me just remind you that increasing the uncertainty goes both ways. It could make things better or much worse. But sure, no, that's an important
fair point. Yeah, Graham.
We do to reduce uncertainty, or at least understand there's at least two streams of activity that I think we need to consider and pursue. We need to define what kind of observations we really do need, rather than just absorb the observations that we have today. Now, I know we are underutilising them, but we've had cloud observations globally for space for 30, 40 years. It's just, unfortunately, not the right kinds of observations. It's also about the critical processes that we need to report. So we need to really think about that. What are the really right kinds of observations? What do we really need? No, we should just be accepting what necessarily is there. We should not get trapped into this mindset that because we have 30 years of that, we have to continue to have 30 years. That's a mindset that community seems to think is a justification. So that's number one. The number two is, we've heard it discussed a little bit over the last day or so, is that the models are evolving, and models are evolving in a way that with resolution changing, in a way that's opening up all sorts of other kinds of opportunities. For example, I've seen these global model results now run at 7, 8 kilometres with a PDF of precipitation from those models, a lot more like what the real world uses. So I think that there's the two streams, model development and moving towards representing the scales of the processes adequately, making the observations of those processes adequately. And I think if we make progress in those streams, I think we can expect to make progress along the way.
So, spinning off the comments that Graham made, I think we should really realize that to a large degree, the aerosol-cloud interaction problem is, first of all, a cloud problem. And the representation of clouds in the model has to be done in a way that's really right. I mean, GCMs have biases when we know them, and they've been around for decades. And one of the reasons why the indirect effect is so strong is because we have biases in the low clouds. So we need to really improve the clouds in the models. And that is something that we really have to say explicitly. That should drive our efforts. And the aerosols plus the clouds will benefit. But we have to really get the clouds first, right?
Can I play the devil's advocate to that? Because I think that we have improved the low clouds in models quite a bit. I mean, for instance, we have started cumulative regimes in a couple of global models in many cases now, and we didn't before, at least not without test argument. And this has not brought down the uncertainties by itself. So I guess, I mean, in answer to Mario's question, I don't think we should expect our models to save the day, at least not by themselves. They might, but they are equally likely to provide more insight into what is happening than to actually guide us to be able to reduce those uncertainty values.
So I think the models are getting better to the point where and the observations are coming together. If we bring them together, we can actually improve the models to get the processes right for the right reasons. We're getting clouds, but we may not be maintaining those clouds for the right reasons in the models. And I think we're getting models that, at scales that you were mentioning, they more resemble the observations now. And we can now start to do more with the observations we have and bringing the models and the observations. I think this works for the aerosols too. I'm just thinking in terms of the cloud problem and getting the processes right in the clouds. We get the clouds to look okay in some contexts, but that may not be the right, and when you're driving a climate for the stratocumulus, that's different than if you're driving the aerosols and the cloud processes for the stratocumulus, for example. So
when you say look okay, can you qualify that for me?
Okay, so look okay in a climate context is getting the cloud gradient effects in the right place with the right magnitude, with the right seasonality, and maybe the right liquid water path. But getting the aerosol effects is a whole nother level that includes the aerosols plus more important cloud processes.
So kind of a nice example of that was the experience that the Aerosol model had when they went from the previous version of CAM 4 to CAM 5. We replaced the atmospheric physics completely. And then the simulations were assessed by some really smart people, and they looked at them and they noticed that the two simulations, present-day climate, were almost indistinguishable from each other in terms of some of their fundamental features, because we've managed to tune them both to look reasonably well. And in a way that makes you despair, because you think, well, what did I do all this hard work for? But then you look at the behavior of them for climate change, for their response to CO2 warming, for their response to aerosol changes, and the cloud feedbacks that are operating under the hood. And the models behave in a very, very different way. And we hope the later generation models are more realistic.
So can I just throw this out there in response to that? You know, just for one of the questions I've asked a number of modelers in this meeting, and I always ask modelers this question, I'm just kind of, at what point do you, or how do you define when you're satisfied? You know, like you say, they look the same, didn't have an effect. And a lot of times we'll say, you know, oh, this particular parameter, this factor isn't important in my model, because maybe
right. So they look the same in terms of their radiative force.
Okay, so it's always like, what do you use as the metric? So
and the precipitation distribution.
Okay.
So yeah, I wanted to just say a word or two in defense of climate data records. We've made certain measurements over a long period of time, not to diminish the value of, in addition, looking at phenomena, doing things like the box model that Donnie talked about earlier, where we look in new ways at a given volume of space. But the climate data records allow us to stratify in a large number of ways and to look for changes in space and in time and the differences, and that's turned out to be extremely useful for many things. And as we get better at understanding the data and as we learn more things, we can make use of the retrospective data in new ways. And I mentioned something about making some aircraft measurements which will allow us to reinterpret the entire aerosol data record that we have for the last 20 years from satellites, just by having better inputs, better assumptions that we can make in retrieval algorithms. So I think you need both. And so then the question comes up, which was something that Andy was talking about earlier, how do we make these choices? I don't think we should be making so many choices. I think we need to push back to a certain amount. And we may not get what we want right away. We're not, okay, the pie is a certain size. But there's going to be a moment, a Sputnik moment, something like that. And then there'll be an Apollo program or a Manhattan project, whatever you want. There'll be more political will to do the things that need to be done. I think we should be ready for that. I think we should be talking about that now and not compromising and saying, well, we can do it for 25 cents. That'll be enough. I don't think we should do that. I think we should be honest about the fact that we do need both. We need the hardware, we need the better measurements, we need the climate data records, we need the field studies, and we need all of that. We really do. It's complicated enough and it has to be done.
Okay, I'm going to follow up on that and sort of open up the can of worms, which we've been sort of dancing around in the sense that we've been saying, right, we need it all. But then we've also heard we need to be better integrated. And we all, I mean, myself included, admit that we've collected a lot of data sets, and then the way we, what I've heard commonly in this meeting is, the way we get more funding is we do the next field study, right? Or, develop the next model or whatever. That's kind of that's the infrastructure behind part of it, but, we all agree that it'd be better to integrate what we're doing. And we haven't for some reason. And so I've heard there's sort of two camps here, right? There's you will say, an optimistic and a pessimistic camp. Have we not done it out of choice, or has it just been out of necessity? In other words, did we really not have the models, for example, to compare against the measurements before now? Now we do, so let's go for it. Or is it something else? And that would be, great to get out of this sort of special combination of people, the thoughts on that. I mean, that's something I would love to get. I mean, sort of dreaming of this symposium, and 5 years ago or whenever we started thinking about doing something like this, that was the hope. So I'm going to open it up, and your hand's up first.
I think we can get better. We talked a little bit about this, at getting better at comparing the models and observations. And we have, I think, the community, both on the modeling and the observation side, has been working together to do that in better ways, with better constraints on models, to bring them closer to observations, and also building some of the observations and understanding what that means and what models are contained in the observations and embedding those in other scales of models. And I think that's difficult partially because of how some of the funding streams work for models and observations, but that's a place where maybe we could apply some pressure.
That's what
to get, because it's not necessarily new money, it's just saying, well, the modelers want to improve, but they should work with the observationalists, and the observationalists, and I think we have been doing a better job at working together and building modeling strategies into observational field programs from the start, for example, or building satellite simulators into our models, and we're getting better at that, but we could continue to push that, and particularly on this issue, I think we can do it, because I don't know that the measurements are hard. The models are just evolving on this issue, and it's clouds and aerosols which are rapidly evolving in how both models and observations are occurring. So this is a particular area where it's been done for other fields. Maybe this is a place to apply pressure to say models and observations together, and a couple of highlights about how to do that would be maybe one way forward.
Well, this is where Aerocom and Aerosat have done a lot of initial work on that.
Graham.
One of the obstacles, I'm going to be crassy, one of the obstacles to doing exactly this, I think, and it's from my past experience, is that, one suite of observations that I think is essential are the global observations. And yet we have model development going on in other agencies, particularly NSF, for example, community model. Now, do you think NSF is going to fund the integration of the satellite observations and models? Probably not, because what they'll say is that's satellite, that's NASA. That's exactly what they say. I'm telling you, that's exactly what they say. So is it up to NASA then to do this model? Well, they don't want to necessarily do a whole bunch of that because they're still pioneering new technology. So it'd be a little crass. We have built this structure artificially, walls between agencies, that make it difficult to do this really integrated science that we want to do.
But I think that's where, like this paper, PMAS, this is, supposed to be sort of more across agencies. We can send a very strong message. I mean, that'd be a great outcome.
I think you've got a great opportunity to send
so
strong messages. This is a great problem because it has so many technicals and so many different parts of science.
Totally agree.
Yeah.
Yeah.
Just a very quick comment on that barrier. We could look back historically for the stratospheric ozone issue. NASA was very important, but so were the other agencies, so I think it can be done.
Yeah, there's a precedent for sure. And it just needs, and this is, as I say, this is the nice thing. I mean, the NSF, our report is more from an NSF, we're thinking of NSF, but this is more broad, right? This would be cross-agency.
Well, and the report, hopefully not just the NSF.
Hopefully it'll impact, right. We'll start right. Yeah.
One thing I think we're not appreciating is when we pitch our proposals, we're not really thinking of the full life cycle of the research problem. We are only tackling bits of it at a time. So if we wrote proposals that really engage people all the way through to the global models every time, I think we would make more progress. But I think we're going to have to refine the question because I don't think we're going to reduce the pre-industrial to present day forcing uncertainty. But there are a whole range of other questions that, if we posed them as a community, we might be able to answer them. I think a lot of questions can be answered from what's been presented over the last couple of days. Just not that particular question. I think we had more questions on the table. We probably have answered some of them by now, but not that one. I don't know what other people think. I don't think the pre-industrial to present day forcing question is going to be answered. We should identify some more, be a bit more positive about what we can do.
But maybe a necessary step to answer it, and might not answer it, but maybe a necessary step, far from sufficient, is we need to understand the present and the processes of Earth today. It may be a necessary step, and that's kind of where I view it come from, because it's all we can really kind of do. I'm not sure about going pre-industrial, understanding these cloud aerosol interaction processes in pre-industrial time. I'm just not sure we know we're ever going to be able to characterise them.
Because that's not been our problem, really.
But anyway, I'm just saying a necessary step is what's happening today. And I don't think we should discount that as being a trivial problem, because it's not. It's a major problem you still haven't got arms around.
Well, I think one of the things I've heard about that is that one of the things that would be needed if we were to make a statement about, sort of different ways of doing things, and this gets back to infrastructure shortness, sort of short-sightedness, I guess you could say, is the way, again, we're funded is sort of in 3-year chunks. Whereas, and monitoring is a bad word. We've heard that, right? We hear that over and over. This is a case. Climate is a problem. I think we need to be able to make the case to the agencies. This is the problem. It doesn't match on 3-year time scales. We need to have, a much longer period. And the CO2 record shows that. Well, aerosol, if CO2 shows it, aerosols are really going to show it, right? And so I think that's another thing, a point that we need to make, that the basic infrastructure behind how we get our support has to be different in this problem, or we're not going to stand a chance at it. Ron?
Well, I guess I worry a little bit about all this data being brought at the feet of models or the head of models, and then say, go and do your best. I mean, you have to understand that most people build models, current models of whatever to address questions.
Right.
And so the models, because of unconstrained constraints of limited knowledge on processes, various mechanisms, have to invoke the best theory or lab that's measurement or something that's available on hand. It may not be relevant at all to a global sense, but they have to apply that somehow because there's no other knowledge. And so, there are lots and lots of things in models. And so you optimize. And kind of that's a key word for me, optimization of especially global models. They have to kind of optimize. So you always get input of new knowledge on some mechanisms and process, which you then make use of. But you frequently find that because in your previous mode, you had a compensation of one bias versus another, and that's why it made for a successful representation or at least a few observations that are available. Now, if you kind of get better on process, you kind of loosen the model, and so it goes off on a different trajectory. And so you now have to go and retune something else on which is core knowledge. So I suspect we're always going to be at the mercy of things we don't know about and we yearn to know about, and for which it may take another 5 years to get knowledge on. So at any given stage in sort of the history of modeling, you're going to have to optimize. But then you're building models to really address questions. That's kind of what the purpose is. So then you have to kind of say, if it's a particular question about aerosol indirect effects, you want to get every process right, so then that's a different question. Versus, it actually does become a different question if you want to address it for climate projections, when you again go into another mode of optimization. So, and I guess, between trying to capture every process level correctly in the global models and trying to address Mario's question about essentially climate sensitivity. Is it a low value, is it a high value, and what is the value that we need so that we can give the value to society? I mean, that kind of takes a little bit different trajectory. You're going to start doing experiments with parameters like, for example, the work that you came at office with a few years ago on exploring the sensitivity of different aspects, including ice physics and other aspects of cloud microphysics. So I think once you're careful that you're going to have to do different things. Having said that, I mean, that may sound like a pessimistic note, but actually there's optimism there in the sense that you can plan something bringing in, you know, the theoreticians, the lab people, the field campaigners, the satellite people, remote sensing, and the modelers. In, you know, what actually has worked successfully in the community, in my opinion, that's the climate process teams. That, you know, there's been a multi-agency agreement, collaboration, brings together people, and, you know, it's kind of had ups and downs, but it's, you know, it's generally perceived upon as a very good way to bring people together. And that might be one way we could think of in the case of the Aerosol-Cloud interactions, where it just, as I think Prather commented on the dedicated unified strategy, that is one way to bring people together, multi-institutional, multi-agency together, which can address, very focus on specific problems, for which you can then optimize models, observations, the combination to get at, you know, the fundamental understanding of the problem.
So in a document that might be written up as a part of this symposium, can we identify specific cases where we went from, let's say, the field observations into a real improvement in the global models, say through advanced theory, parameterization, tuning, or development? Can we identify a few of those test cases that could be used as an argument to show the agencies that this is possible? And it has been done before with great success. And this is what we need to follow with some tweaks, say, as a paradigm.
Yeah, I mean, I was thinking of that direction. I was also thinking of the other direction. There's been a few recent cases, I think, Vocals and other ones have been mentioned as cases where modelers are, you know, have come in and stepped in and said, Rob did, you know, where you say, where should we go? You know, there's multiple ways where there's been a synergy. And so I think that's something sort of introductory material, that there are case studies that it's worked. I mean, it seems reasonable, but yeah, I mean, that it's possible, but we just need, you know, to advance that, and how would we add on to that, I think is something we would definitely should be thinking about.
And I apologize, Thanos is also on this committee, so you can direct comments to him. Sorry I missed you, Thanos.
Were you going to say something, Mario?
No, there were some hands up.
Oh, hands up there. Oh, you know, you're, okay. You're right under the light, sorry.
I'm going to stand back even further. I'm not sure how to go. I think it's become obvious that atmospheric sciences in general really fit very nicely up into what Don Stokes would have called Pasteur's quadrant, which is a use-inspired basic research. And if we can capitalize on that, which is really then a sort of a globally integrated approach to science, because we're all scientists, we all operate related and we practice in a large sense that transcends governments and even countries. If we could collectively get together, more like what you would expect up in that quadrant, which is more of a biomedical-like approach, as opposed to a Manhattan-like approach. It's a biomedical approach, which isn't too far, really, from James Lovelock's idea that we're sort of planetary physiologists. If we put ourselves in the sense of a planetary physiologist, which I think people naturally then sort of get a sense of as being something relevant in the immediate and in the long term, and something that you should have very large capital venture investment in. It goes beyond governments. You know, some of these guys in Silicon Valley to latch on to developing technologies, whether that's new satellites or whether it's new ways of heating your house. We're not too far from it, and it seems that somehow we've got to perhaps to get to where we're all asking for. We're asking for more modelers, to work on better models, to work on better computers, to get more observations to assess these better models. And if we're really going to get there in time, because we're kind of running out, then it seems that somehow we've got to sort of break out of this mold of sort of discussing the details, because we're all pretty familiar with the details of what we would like to have happen in the context of our careers and that. But in the longer term, how is this really going to play out with the budgets that we're suggesting are going to be necessary to make some real advancements, sort of like the biomedical advancements. And in the budgets that they have, because it just makes us look.
Ours are staying flat.
Yeah, so, I mean, is this what is that going too far in the?
No, I mean, I mean, we all sort of want to, in my view, and I don't know whether it's just sort of, I feel like we all just sort of would like to stay sort of in the comfort zone in the way that we're used to doing things, but just do it better, or do it differently or something. But I agree with you that, especially from a funding perspective, and the way funding is done, I'm not sure we're going to get there either. We were throwing out I think Ian threw out $100 million. He was giving out $100 million. But then people were starting to say, but we have to move it from somewhere else, right? And so that is a question. What, if we had unlimited funds, what would we do? And what would be everybody's first choice? I mean, I kind of, personally, as a measurement person from the modeling community, I asked almost every model where I went into, somebody could measure something, somebody could give you one variable, what would that be that would help you the most? And, we haven't really, I've got independent answers on that, and I don't know if people have opinions on that, but that's as a measurement person, I would love to know that.
See, but $100 million is not much.
Okay, no, it's not. I agree. $100 million is nothing. I agree. It's like, I totally agree. We were just talking about one little chunk, but Ken.
Well, I was just going to comment, the biomedical thing, NIH had their budget doubled over a period of 5 years. And I think really they did it largely because they had a lot of public support, because we can all identify, especially as you get older, with various diseases and so on. And, people can identify with that and say, yes, our tax dollars are being well spent because it's something that may affect me or my neighbor. And I think that's where Mario's comments on policy are very important, because I think the tone of the conversation is changing. But I don't think we've done a very good job of telling the public, why what we do is important and how it's going to affect them personally. Now, the message is starting to get there, but I don't think we've been very effective. And I think that's one thing we need to do better if we're going to see anything other than flat budgets. And it really gets to Mario's comment about policy and how you translate what we do.
So two thoughts. One of them is, I don't think it's one measurement. I don't think there's one magic measurement. It's a system. We have to do all these pieces together in some coordinated way. And as far as getting the resources and getting the public on board, my thought is that that's probably not going to happen regardless of what we say until the Earth shows up. And the Earth is going to show, we're perturbing the composition of the atmosphere and the ocean. And sooner or later, something big enough will happen, bigger than Katrina or Sandy, bigger. I'm not sure what it is, but it's going to happen. We all kind of know that. We don't know when. We're not sure which of half a dozen possibilities it'll be. But that's the point at which public opinion is going to have a tipping point. And the media are going to switch from this business of contrarians and scientists talking to the public is afraid. And then several things will happen. One of them is that there's going to be resources that we can't even discuss at this point. And secondly, the pressure on us to answer questions is going to be enormous. And we better be ready for that, because it is going to happen. And you're going to want to know why we don't have the answers already and all that sort of thing. And well, then we'll have the beast and Penman at the same time, I guess, but that's...
You may be right about some, I don't know if you use the term catastrophic event or not, but looking back at air pollution, for example, in Southern California. So I arrived from clean Canada in 1970, and I couldn't see the big C on the hill a quarter of a mile away in Riverside. And we know now that a lot of deaths were caused by the particles and so on. If you look at what happened there, it really happened over a relatively short period of time, not as short as the CFC case, but there was no catastrophic event. It was a series of insults where children couldn't go out at recess. They wouldn't have recess. People knew they couldn't go out and jog, in the middle of the day. So there was just a constant drain on lifestyle and a sense that it was affecting health, but the data really were not there at that point. And they are now, of course. But so, in that case, in California at least, over a period of about 10, 15 years, interestingly, with the same chair of the California Air Resources Board who's in there now, Mary Nichols, and the same governor, Jerry Brown, over that period of time, they instituted regulations based on science, good science, that really made a dramatic increase and improvement in air quality. So, for example, over about a 20-year period from 1985 to about 2005, 2011, peak ozone in Southern California has gone down by a factor of something like 3, while vehicle miles traveled, the major source of emissions, has gone up by a factor of 2 or 3. So in that case, there was a tremendous amount of public support in the 70s that said we're being affected with our lifestyles, and it wasn't really a catastrophic event. And so, I'm not sure we have to wait for a catastrophic event. Maybe we need to do a better job of communicating how this is affecting people now, and maybe in more subtle ways.
Was it a matter of the way in which scientists communicated to the public, or was it just a small enough problem that it could be solved regionally rather than globally, or?
No, it was a lot. It was a lot of communication of scientists to the public, and I'll put in a plug for my husband, who did a lot of that at the time. And it was a lot of communication to the public, which gave the regulators the backbone, if you will, to institute some things that were quite unpopular with some of the industries, but they knew that the public was behind them because the public understood that this was an addressable problem and that there was enough science behind it to know that if you took certain steps, it was going to have a measurable impact.
Yeah, just want to pick up on the theme of catastrophe and then what Mario was saying. In the business as usual scenario, we are talking about 8 to 9 watts per meter squared forcing. In that context, if you look at this aerosol-cloud interaction, is it half a watt or 1 watt? Really not going to matter. Because that half to 1 watt will disappear if we clean up, or it'll be there. But I think the aerosol-cloud interaction problem may become a huge issue. If such a catastrophe happens, there's going to be a call for a geoengineering to do something to fix it. So it's in that context that the aerosol cloud would rear back again, because that's something we can do on our backyard. So I'm wondering whether our observations should be more to understand interactively as opposed to passive observations. We go, put stuff in the clouds and see how they respond. Honestly, that's what the models are all doing. You're doing a partial derivative. You're not looking at a coupled system. So your model may be better tested by going and pumping something in the air and seeing how the system changes. But on the larger scale of what Mario is saying, I don't see how the aerosol cloud problem is the major issue there. We are talking about half to 1 watt. The CO2 forcing is going to be 9 watts per meter squared.
Okay, maybe I can make a comment, but it's more on science policy so that we have something optimistic as well. And here is it. First of all, on the funding for science versus NIH, Barbara, you're right, but it's not the public, it's the congressmen, of course. They are the ones that do the budget, and they're the ones that were very willing to increase NIH. But we at PICAS, this scientific advisory board to Obama, so we meet with congressmen. We were very proud that the last budget, we broke that rule. So the budget for science increased, whereas the NIH budget did not increase anymore because that was already being very large. Now, the other side of the coin could be, if you're talking about Congress, Republican Congress, and climate change, we would be in deep trouble because one of the ideas is that we are all just seeking more funds. The climate change issue is not necessarily an important one. But fortunately, again, talking to individual congressmen, they recognize that this is important research, and so at least the funds for NASA and so on are not going down, except that it's all vulnerable for the economy. So that's another comment. But a third one in terms of catastrophes, first of all, we already have extreme events. And so that's what is changing public opinion to a significant extent. But of course, we in the scientific community have to do a much better job communicating the risk, not necessarily what will happen. And because you can connect extreme events in terms of probabilities with climate change. But my optimistic note is the following, that enough companies are now switching sides, if you want, and enough of the public is realizing that this idea that some scientists think one way, but many other things the other way, that's a myth, that there's really an overwhelming consensus that we do have a problem. So the hope is that we can act soon enough. So we, hopefully, other than more extreme events, the hope is that we can avoid these catastrophes. And so that's a big science policy issue, if you want, and that's why we want to be able to say that, to make sure that we start doing things about this problem, because that's not what we're doing now. We are on the high emissions line. Yeah.
I'm going to follow up on that.
Yeah, and it's partly a follow-up on Ram as well. But, you know, you mentioned the future could be 1 or 10 degree increase. And that range, it's true, the future aerosol forcing may be only a minor amount of business as usual, but that range of temperature depends on what our understanding of the aerosol indirect effect in the past, from pre-industrial to present day, is. That's why this is an important problem. And you know, saying if it's small, then you know, we can expect 1 degree. If it's very large, we can expect 10, and we need to figure out that range.
That's uncertain.
Yeah.
Okay. I think we're going to close now, and so I would like to first of all thank co-organizers John and Ian for all the work on this, as well as the NRC staff, Ed and Christina, for the work that they've done to make this a possibility, because it's been a lot of work and a very busy time for them, and they've done a great job, so thank you. And last but not least, on behalf of the co-organizers for this symposium, we've really enjoyed it, and all of your input has been fantastic, and we look forward to working with you as we move forward towards a product for this colloquium. So thanks again for everybody for all your contributions and your time in being here. Thank you.